This is the last video for Integration by Parts, section 7.2. This is video number 5. Now, when you're looking at this particular example, you'll notice that this is not two different functions multiplied together. So there are certain cases where integration by parts might be something you're going to want to attempt. This is, again, one of them. Now, the second detail that you'll notice about this problem that's different than the others is the fact that I have bounds. So we're going to have to make sure we feel comfortable with evaluating the bounds on these integration by parts problems when they're there. As well as, don't forget that these are cookie cutter, and yet there are some times that cookie cutter might not be exactly the same as all the others. So I'm going to let u equal a function. I'm going to let dv be equaling a function as well. And again, this still follows the exact same rules of integration by parts. The difference, however, is you're going to have to recognize that, well, the natural log of x is a logarithmic function. So now we've dealt with algebraic, we've dealt with exponential, we've dealt with trig, and now we're going to be dealing with log functions of some form or another. Okay, so there's an arrangement on what you're going to let u equal to in some form. Now, I'm not going to write out the exact arrangement of every single function and how you see them. I'm going to let you go ahead and work through those on your own with practice. But in this particular case, if we try to let u equal the natural log of x, the statement ends up being, well, what's left for the dx piece? Well, it would just be 1 dx. So the argument here was I could let u equal the natural log, or I could let dv equal the natural log. But again, if we're looking at this problem, off the top of your head, you do not know the integral of natural log of x. You know that the integral of 1 over x is the natural log of x. You also know the derivative of natural log of x is 1 over x. So that would force us to say that maybe I want to let u equal the natural log of x because I actually know that derivative. Where dv would be, well, what's left over? 1 dx. So yes, at this point, looking at this integral, we would have to say that, yeah, by taking the derivative of natural log of x, it kind of makes things more complicated because it changes the natural log function to a rational function with the dx. And by taking the integral of 1 dx, it actually adds a power of x to the whole problem. So with that, we'll notice that we have more x's in the problem than we did before. However, in doing so, let me create this very carefully, equals to, well, u, v, again, like it's always set up, so x natural log of x, minus the integral of v du. So x times 1 over x dx. Things that you're going to want to make sure you remember. Technically, this thing right here is an integrated part, so I should have x equals from 1 to 2, because this thing must be integrated on those bounds. You don't have to write that piece in there. I'm writing it in there to show you that this part has been taken out of the integral, so it must still have those bounds on it. This also still has to have the bounds on it because it has yet to be integrated. So my next step is to integrate this integral right here. Again, I'm not going to deal with these bounds yet. I'm going to deal with those bounds all the way at the end. So I'm going to, again, leave the bounds out from this point forward. Again, I won't take off any points if you do the same. So the integral that you're left with here is the integral of, well, these two things just cancel out and leave us with just 1. So this integral actually becomes quite nice as the integral of 1 to 2 of 1 dx. So therefore I end up with x natural log of x minus the integral of 1 is x, this whole thing evaluated from x equals 1 to 2. And again, I don't need a plus c on here because that is my actual integral, okay? And the fact that I have these bounds on the end. So if I were given the integral of natural log of x dx all by itself, by using the integration by parts, we will come up with the formula x natural log of x, minus x plus c. This is the formula that you can have memorized, identified, written down. It's one of those ones that might come up every once in a while, and then we should be able to feel comfortable identifying it clearly. So down here, to finish this problem, we're just simply going to plug in the bounds and do the exact same thing we did in the past. So 2 natural log of 2 minus 2. That is me plugging in 2 for the first piece. Minus, now I'm going to plug in 1. 1 natural log of 1 minus 1. Keep in mind natural log of 1 is nothing more than 0. So this whole term becomes 0. And very carefully I get 2 natural log of 2 minus 2 minus 0 minus 1. Again, I'm writing that 0 in there because I don't want to make a mistake with this negative stuff. In which case this ends with 2 natural log of 2 minus a negative 1, which is plus 1, so minus 1. And that's as far as I can go because, again, this natural log of 2 is inside the natural log, and this 1 is not inside of a natural log, and I can't combine it with anything else. And again, that's how you deal with the natural log in terms of the integral. It's also how to deal with bounds on a integration by parts problem. Again, you plug them in all the way at the end.